Okay, so this is where I believe we left off. So this question asks, find the critical values or value for the indicated z-test in the level of significant alpha if it's a left-tailed test. Remember when we use the z, that left tail is how it reads. So you have your... Okay, sorry, I'm not sure where I left off. I had someone come into my classroom. Okay, so now we are trying to find that critical value. It's a left-tailed test. Since this is a z-test, remember z-tests always are the table in the back always reads to the left. If it was a right tail for this, you'd have to do 1 minus your alpha. And that's what you'd look for in the table, but since this one's left, you just go along as it is. If you go to the back of the book, you're going to see that your critical value should be negative 2.05. So number 13, use a z-test to test the claim about the population mean at a given level of significance alpha using given sample statistics. The claim is that that mu is less than 5.5 and alpha is a 0.01. The sample statistics, I couldn't make it x bar, so again, no, there's an x bar there, and then we see those. So let's start with the beginning of this, writing our null and alternative hypothesis. So your null hypothesis is mu is greater than or equal to 5.500. Your alternative hypothesis is what's given, so that mu is less than 5.500. So you see that this one's the claim. With this, we now have to go to the back of our book, and we want to find the alpha with this. So you see that using the HA, which does not look much like an HA, so I'll make that better. This tells you that it is a left-tailed test. You're going to go in the back, and you are going to find your z value associated with alpha. Take a second and try to do that if you haven't already. So what you see is that you get an alpha, with that alpha, the z-score that corresponds to it is negative 2.33. Then we had to calculate our z. So when we do this, we want to calculate it using that formula. So x bar minus mu all over s divided by the square root of n. So that's 5.497 minus 5.500 all over 0.011 all over the square root of 36. When I put this into mine, I ended up getting something negative 1.636. So if you look at that, you see that that is not in your rejection region, so you're going to fail to reject. Again, you can do that by looking at it and seeing if it's less than this, or you can actually do it by creating your distribution. You know that this is negative 2.33. You know your negative 1 is going to be out here, negative 1.636. You see it's not in that region. And then we had to create the statement. I'm going to write it up here. There is not enough evidence to support the claim. And again, this comes from that chart we had where you know that your claim is your HA, the alternative hypothesis, and then you know that you're failing to reject, and then you select that box. Okay. So we're back at it with number 14. So test the claim about the proportion or the population mean using rejection regions or p-values. A tourist agency in New York City claims that the mean daily cost of meals and lodging for a family of 4 in New York City is $326. You work for a consumer protection agency or advocate and went to test this claim in a random sample of 50 families families of 4 traveling to New York City. The mean daily cost of meals and lodging is $318 with a standard deviation of $25 at an alpha of 0.05. Do you have enough evidence to reject the claim? So again, you begin by stating your null and alternative hypothesis. So we see we have HO is mu equals 326. That's our claim. And then HA, mu does not equal 326 because remember this is the complement. Make that look more. Okay, so now we're going to use the z equals x bar minus mu over s to calculate r of z. So it's 318 minus 326 all over 25 divided by the square root of 50. Negative 8 over 3.536. So that's the value I got when I put it in my calculator. Hopefully you were able to get something like that as well. So I looked in the back to see the area. Hold on. So I looked in the back to see the area associated with the 0.05. Remember, this is two-tail. And then I went and looked for the area associated with my okay, sorry for the confusion. I wasn't sure which method I used for this. So when I did it, I did the p-value method. So p-value, remember, and then this is going to be 2 times to the area to the left of your negative 2.63, which is 2 times. If you look in the back for that, you'd see that's 1.2, 0.024. So your p-value is less than your alpha because 0.024 is less than 0.05. And this tells us that we reject HO. And then the statement that goes with it is there is sufficient evidence to reject the claim. Okay, so number 15, find the critical values for indicated t-test, significant level of significance alpha, and the sample size. So it's a two-tailed test with an alpha of 0.05 and an n of 20. So you go into the back of the book, you're looking at two-tailed test with an alpha of 0.05, and you will see that you end up with t equals plus or minus, remember since it's two-tailed you have to account for both the positive and the negative, 2.093. Remember, if it's the left it's going to be the negative, if it's the right it's the positive, and then two-tailed we account for both of them. So now on to number 16. So number 16, use a t-test to claim, test the claim about the population mean and the given level of significance alpha using the sample using the given sample statistic. Assume that the distribution is normally distributed. So now your claim is that mu does not equal 95. So that's going to be my alternative hypothesis, because remember my HO is always with the equal. So HA is that unequal. This is my claim. With this, we want to go find our critical value. So if you look in the back of your book, since this is a two-tailed test, you have plus or minus, and then if you flip back there, you have an alpha of 0.05, degrees of freedom of 11, which brings us to 2.201. Now we calculate our t value, x bar minus mu all over s divided by the square root of n. 94.1 minus 95 all over 1.53 divided by the square root of 12. If you simplify the numerator, you end up with negative 0.9 over 0.442, which is approximately negative 2.038. And we see that we have to fail to reject. So we see we fail to reject. HO, and we say there is not enough evidence Not enough evidence to support the claim. And again, we got that from that chart. And if you actually wanted to draw this out, you'd have your t-distribution. Remember, it's the metric amount of the mean. And then we see over here, we have negative 2.201. Over here, we have positive 2.201. Shaded in, shaded in. With this, we see that our value of negative 2.08 is just not in there, and therefore we fail to reject. So in case you didn't see that. Well, I just solved this problem, but I did realize I didn't have it recording. So again, this one's just asking us to see if we can use the normal to approximate the binomial distribution, and if we can to do it, and if not, let them know. So what we test is to see if n times p is greater than or equal to 5, and if n times q is greater than or equal to 5. So here we see that we have n times p, which is going to be 45 times 0.08, and then over here we have 45 times q, which is going to be 1 minus 0.08. When we do this, we see over here that we end up with 3.6. 3.6 is not less than 5. So normal distribution cannot be used to approximate the binomial distribution. So no, can't use to approximate the binomial. So we are now on to our last page. We see that the next question is test the claim about the population proportion. A polling agency claims that 40% of adults shop for a gift within 1 week of the event. A random survey of 2,730 people in the U.S. 1,137 shop for a gift within the week. Test the agency's claim at an alpha of 0.1 level. What can we conclude? The goal is so it's P I'm not sure where I got the 8. So we see that it is claims that over 40,000. Okay, so I solved the wrong problem, so I had to go back and then resolve this one, so I apologize. So now we see that it claims that over 40% of adults shop for gifts within the week. So we see that P is greater than 0.40, which is my claim. And we see over here that P is less than or equal to 0, which is 0.4. When we go into the back of our book to look for the alpha that's associated with this. Now remember, this is a right-tailed test, and then our alpha here is 0.1. The z value that's going to be associated with this is 1.28. We have to calculate our p hat based on the information given, and that's going to be x over n, which we have is 1,130 over your total of 2,730, which we get approximately 0.414. Now that we have that, we have to calculate RZ for this problem. So you have to use that formula. So that's p hat minus p all over the square root of p times q all over n. So we end up with 0.414 minus 0.4 all over the square root of 0.40. Remember, q is the complement, so it's 1 minus that, so this is 0.60 all over 2,730. In the numerator, you see that you end up with 0.14, and in the denominator, you end up with 0.0094, which is approximately 1.493. We see that we can reject the null hypothesis. It will be within the rejection region, so reject null. And then we had to make that concluding statement. So there is enough evidence to support the claim. There is enough evidence So again, sorry about that one. Didn't mean to solve the wrong one. Okay, we are now on to number 19, which we should have enough space to do on here. Number 19 doesn't really require much. So this is to find the critical values indicated for the chi-squared test for the population variance, sample size n, and the level of significance. So this is a right-tailed test. Remember, the area to the right is what this table reads. You have an n of 20 and an alpha of 0.05. And we go look in the back of the book, you're going to run into your value of 30.144. So 30.144. Okay, and last but not least, we're going to use this test to test the claim for the population variance and sample deviation at the given level of significance. Assume it's normally distributed. It tells you what your claim is. So we see here we have our null hypothesis and alternative hypothesis. Sigma is less than or equal to 2. We see that our claim is sigma is greater than 2. Get from right here. We're going to calculate our chi-squared value, which we use that n minus 1 times s squared all over sigma squared. This is going to be 17 times. We ended up with s squared right here, 2.95. And then this one we see is 2. When you put this in there, you end up with 25.075. So now you remember that this is a right-tailed test based on our alternative hypothesis. So this tells us it's right-tailed, which is what the chi-squared distribution already reads. And so we're going to go in the back of the book. You're going to look for your degrees of freedom of 17 because it's 18 minus 1. You're going to look down the alpha level of 0.1. And if you look there, I'm looking it up with you, you see it's 24.77 if I'm not mistaken. So you'd see here in a distribution that's not symmetric, so you know this isn't going to be pretty. Probably not very accurate. Let's try it again. Yeah, it's ugly. Imagine that it's actually true. You'd see this is your 24.77 shaded region, and then your value, we just calculated as 25. It is inside that region, so we see we can reject. So that's at 25.075. And so we reject HO. I'm going to write my statement above. So there is enough evidence to support the claim. There is enough evidence to support the claim.